Well, welcome everyone to the second annual Massachusetts Climatetech Studio Showcase. Let me see my picture there. I am Allison Kaplan, the program manager at FedTech, and I'm delighted to be your MC for tonight's pitch competition. So, we have 9 incredible teams pitching tonight, so I'll be keeping us on schedule to make the most of your time and theirs. Let's see, here's our plan for this evening. After some brief introductions, we'll have our first 5 pitches, followed by a short break for refreshments. There is food over there, so of course at any time you're welcome to get up, stretch your legs, grab some food. Just please be respectful of our speakers and our pitchers. And then after that break, we will have our next and final 4 pitches, followed by judges deliberating, and then we'll wrap things up right around 8 p.m. with our prize awards. That's right, there is cash on the line tonight. Thanks to our studio partner, MassCEC, the top 3 teams will receive funding. So $50,000 for first place, $30,000 for second, and $20,000 for third. You can refer back to this agenda and read more about each team in our handy digital event guide. So if you scan the QR code on the screen, or if you have a lanyard, it should be on the back of your name tags. And the schedule is just on there. But be sure to look at the full event guide to get more info on the 9 teams. All right. So before we get to the pitches, let me give you a bit of background about the studio. So powered by MassCEC and FedTech, the program takes early-stage climate technologies that we source from university and national labs, pairs them with a diverse team of entrepreneurs to explore commercialization, form a business use case, and ideally license that technology to spin out a startup. So after a very competitive application process, each participant that you'll see here tonight was matched with one of these technologies and a team and immersed into this unique journey into entrepreneurship. We started with a Saturday boot camp way back in April, followed by 16 weeks of Wednesday evening workshops, many meetings with their coaches and mentors, and of course, customer discovery calls. They did this all while balancing full-time jobs, grad school, and, well, life. So it's been super inspiring for me to watch them all do the work, and tonight we get to see the end results. Yet for many, the showcase is hopefully just the beginning of ventures that will drive real climate solutions and positive impact across Massachusetts and beyond. So as I said, this all starts with the extraordinarily innovative lab technologies that our team, in particular Justin Mahan, has the privilege to steward. So we want to wholeheartedly thank our tech transfer partners and inventors at Sandia Labs, NREL, UMass Amherst, UMass Lowell, Northeastern, WPI, and MIT. Many of them are here tonight, so let's give them a round of applause. And the studio is, of course, made possible by our wonderful partner, the Massachusetts Clean Energy Center. So it's my pleasure to introduce Jen LeBlond, the Managing Director of Emerging Climate Tech at MassCEC.
Hi, everyone. Hi, everyone. Good evening. I am so happy to be helping out at this second annual Massachusetts Climatetech Studio Showcase. And it is amazing to be part of this Startup Boston Week. So I wholeheartedly thank Suffolk and the Startup Boston team for making this happen. I've been looking forward to this event, and I know the teams at MassCEC and FedTech have really been looking forward to it too. It's great to see so many familiar faces in the room, and it's fantastic to see new ones as well. So first, I just want to extend our thanks to a couple of special guests. If they're not in the room, know that they're here in spirit, and we really are grateful for their support. So Climate Chief Melissa Hoffer, and we may find Deputy Schrag around here at some point this evening. Thank you for implementing this whole of government strategy to tackle the greatest challenge of climate change. We also want to extend our thanks to State Representative Stephen Owens from Watertown for joining us. We wouldn't be here today if it wasn't from support from our incredible state legislators. Also, staff from Boston Mayor Michelle Wu's office in the City of Boston. We're grateful for the administration's partnership on many of our programs at MassCEC. Undersecretary Catherine Antos from the state's Executive Office for Energy and Environmental Affairs. We work so closely with EEA and are so grateful for the support and guidance and leadership of Secretary Tepper and the entire team and their commitment to clean energy and climate innovation. So as was just said, my name is Jen LeBlond. I'm the Managing Director of Emerging Climate Tech at Massachusetts Clean Energy Center, known as MassCEC. I first want to start by extending my thanks to the amazing team at MassCEC. It's not just the Emerging Climate Tech team that's here, we're also represented across the division, so thank you. Again, gratitude goes out to my FedTech partners and colleagues in this amazing venture. So thank you, everybody. It's been such a pleasure to work with you in this second cohort. So I want to extend a really special thanks to the ecosystem partners who've contributed to Mass Climatech Studio's success. We're grateful to everybody, including those in the room, who've hosted events, who've connected with our teams, who've helped really strengthen and solidify this ecosystem. And speaking of you guys and this amazing audience, thank you for being here and spending your time. I am sure you're going to either learn, be inspired, or have an array of emotions as these startups pitch their sessions. So thank you. I want to acknowledge that really this has not been an easy year for our state's innovation community. And what's happening at the federal level, I think we can all understand, is extremely disturbing. But I want to assure you that Massachusetts is not backing down from what we're doing best. We're solving big problems that inspire global change while powering our economy here at home. So state leadership is more critical than ever. And that's why our team at MassCEC is traveling the state, hosting our Climate Tech Corridor Roadshow. Now try saying that after too many beers in the pub. To bring together core members of the climate tech ecosystem. So that's all you guys, innovators, entrepreneurs, local officials, industry representatives, and others in each region. During these visits, we're bringing together the community to understand MassCEC's Climate Tech Economic Development Plan, which is our 10-year strategy to make Massachusetts the global hub for climate tech. And Climate Studio is just one of the ways, one of the programs that we're making this happen. Some gaps hinder innovative technologies from reaching their full potential. First, it's often that IP gets stuck in the lab. And so we're fortunate to have Massachusetts as the home to world-class universities and colleges, from UMass to MIT to Suffolk. And our institutes attract these brilliant minds that are tackling the world's greatest problems, and specifically those problems in climate change. But these innovators often lack the necessary resources to commercialize their ideas successfully. And groundbreaking technology isn't going to break ground if it's stuck in the lab. Technology isn't going to reduce pollution or protect our communities or reduce energy costs or help us build resilient structures or improve our quality of life if we can't bring it to the market. So another gap is that there are entrepreneurs who want to be involved in the climate tech sector, but Massachusetts ecosystem lacks a venture studio. And that venture studio really can help connect the innovators from the lab. So in this venture, MassCEC has partnered with FedTech to address these gaps and launch, as Alison had said, the 16-week intensive programs that really pairs the entrepreneurs with the IP and gives them structured support to foster teams, and that means they succeed. So we're here tonight to hear the pitches from 9 teams, part of our second cohort. And they'll pitch their technologies in front of this esteemed set of judges who will determine the winners of this year's studio. So no matter who wins, I want to recognize every team and every member in the room. So while we're at the teams and the members, can you raise your hands, please, and let everybody know? And they should be wearing these green lanyards. So I encourage you to talk to them and connect with them after the event itself. What you guys have done is not easy. Your participation in Climate Tech Studio took a leap of faith. and a lot of energy and a lot of time out of your busy lives. So I hope these 16 weeks have been meaningful for you. I hope you've learnt valuable lessons and overcome those tough challenges and form lasting connections within your teams and competitors within your ecosystem. And I want every participant to know that Massachusetts wants you to succeed and stay here in Massachusetts. When someone starts running a business in Mass, they invest in our communities. We invest in startups because they have the potential to drive growth in our local economies, and they create jobs and they generate economic activity across the state. We invest in them because their technologies they've created have the potential to improve lives, and improve not just Massachusetts' lives, but lives around the world as we face this greatest challenge of our time. So thank you again to all the teams for your hard work. You're just addressing that small challenge of global climate change. Thank you for your hard work, your spirit, your commitment to solving challenges. And thank you again, everybody here who's supporting this venture and growing this climate tech community and ecosystem. And now I'll hand it over to Ben from FedTech.
Hi, everybody. Thanks to Jen, MassCEC, and really the Commonwealth for having the vision to create this type of program. My name is Ben Solomon, and I'm the founder and CEO of FedTech. I'll talk a little bit about what we do in a moment, but just want to also acknowledge kind of what our entrepreneurs have gone through. So we, in many ways, it's kind of the combination of the first day of college mixed with doing math in public, mixed with meeting many people that you don't know, is what we put them through, where we form teams, of people that are often brand new, right? So we're really, creating companies from scratch, introduce them to a researcher in a lab that has a technical expertise that really only, usually one or two people in the world can fully understand, right? We force them to get spun up on that technology and then get out into the real world and do customer interviews, quickly learning and iterating and coming back every single week with what they've learned from that process. So I just want to acknowledge the experience of the entrepreneurs that they've gone through. Thank you for being part of this process. A little bit about FedTech. So we are a venture accelerator based, we have our headquarters in Washington, D.C., but an office here in Boston that we're incredibly proud of and committed to growing to being a part of the Commonwealth's amazing innovation ecosystem over time. We run programs like this where we spin off technologies from research labs. This is what we call our startup studio. We also run a number of seed and Series A stage accelerators, often in partnership with large government sponsors. We train thousands of researchers on entrepreneurial topics and skill sets. And really proud of, we just passed our 10th anniversary this year and have worked now with 1,000 companies that have gone on to raise almost $5 billion of follow-on capital. So in that process of getting to see many great companies, just wanted to offer really kind of 3 points of advice for our founders. So the first is really to embrace the technologists that you work with and your lab partner, right? They're going to be the pipeline to so much of not only your future product development, but funding opportunities, growth of the business. So really, and learn what their objectives are, bring them onto your team, even if they don't. A lot of times our technologists and our inventors don't fully join officially the startup, right? That's okay, right? But they're always going to be a strong partner. So really encourage you to embrace that. A second piece of advice is move quickly. So I was really excited. We got to hear the practice pitches last night, which were all terrific. We're in for a real treat. And I'm hearing about our founding teams already negotiating their licensing agreements, already starting to look at funding opportunities. Too often I see young ventures that have a highly technical product that takes a long time to develop, move slow out of the gate, right? And I would say, move fast, right? Don't wait, get your application in for your license, write the proposal, right? Take the extra meeting, go to the conference, right? Even when you're tired, do all these things and scramble like your life depends on it. Because as a young venture, it really does. And then just the last piece of advice, comes from really my personal experience of building FedTech over 10 years, that every stage of this process is special. You learn new things, you make mistakes, you learn from those mistakes. I always likened it to, a child touching something that's hot, right? When you're in a venture, if you touch something that's hot and you make a mistake, okay, I'm not going to do that again. if I do something that feels good and is, productive, I'll, okay, do more of that. So really embrace this just as a unique period in your life that goes very quickly. Before you know it, you do, inevitably scale and you start to have a new range of challenges. So embrace this period in your life. And FedTech is really here to help you at every step of the way. And let's get on to the pitches. So we have, I think Allison is back up.
All right, thanks, Ben. Okay. Of course, tonight, as I said, is a pitch competition, and you can't give away $100,000 without some judges. So let me briefly introduce our esteemed panel. We have Sam Waters and Brooke Nadeau from MassCEC, Naval Singh from St. Gobain's corporate venture capital arm, Nova, Amelia Thomas, co-founder and CEO of River Otter, and Edison Almeida, serial entrepreneur and director of new ventures at Analog Devices. So thank you so much in advance to our judges. All right, let's dive in. So each team will have 10 minutes on stage. That's a 5 to 6 minute pitch. Then their team will immediately join them up on stage for 3 to 4 minutes of questions from our judges. So please, if you can, maybe hold your applause until after the Q&A while the judges get some time to finish their scoring, and we'll transition to the next pitch. Photos are welcome. Please just turn off your flash and ensure your phones are on silent. Alrighty. I am pleased to introduce our first entrepreneur, Karina Celine with Ava.
All right, good evening, everyone. Thank you so much for being here, and thank you to Suffolk University for hosting this event. Before we get started, I want to ask you all for a favor. Is that okay? Good, thank you. Please raise your hand if you've eaten seafood in the last year. Yeah, great. You put your hands down. Now, please raise your hand if you've eaten plant-based seafood in the last year. We have a couple. Yeah. That difference is the problem we're here to solve. We're Ava. We're revolutionizing seafood. We make plant-based seafood that actually tastes good. Here's the problem, and you're not going to like it. Seafood isn't a sustainable protein. Seafood is traded 8 to 9 times before it reaches your plate, and each one of those trades increases the carbon footprint, and it increases the final cost to the consumer. You can see on this chart that seafood ranks above pork and poultry and only second to beef in terms of greenhouse gas emissions. And unfortunately, farmed fish isn't the answer. It emits 54% more greenhouse gases and uses 8 times more fresh water than wild catch. So if seafood is this unsustainable, why is everyone in this room not switching to plant-based options? Yeah. We surveyed people across the country. We did taste tests, and overwhelmingly, texture is the problem. These are some quotes from the taste test, and my personal favorite is, if you give this to a seagull, do you think that they would eat it? I would say probably not, unless that seagull was really, really, really hungry. We have a breakthrough. Our technology mimics the authentic, flaky texture of fish that we love. Developed in the lab at the University of Massachusetts Amherst, we have a patented technology that aligns denatured plant proteins with plant fibers and extrudes it through a custom die head. You can imagine this sort of like 3D printing, but with fiber alignment that you would see in a muscle structure of an animal or a fish. And it's not just like regular extrusion that you might find on the market today, which is both capital and carbon intensive. And extrusion sometimes creates something that's fibrous and mushy, which is leading to the texture problem. We have a big market opportunity. We know from the research at the Good Food Institute that omnivores are actually really interested in trying plant-based options. I bet there's a couple in the audience right now. But you have to meet taste, you have to meet cost, and you have to meet the nutritional expectations that they honestly deserve. So we're going after the entire seafood market. The global market is $368 billion, the US market is $31.5 billion, and we're going after just 1% of that, starting in New York City and Boston. And we have a competitive edge. We compete both on texture and on price. Our proprietary lamination process replicates the seafood fibers better than anything on the market, and we use affordable ingredients, and our supply chain is modular, which is really exciting. Here on the stage, that I think only half of you can see, is a miniature version of the bioprinter that we use in the lab, and it was built by my co-founder, Jennifer, here. So you can imagine that we can scale this up. Oh, thank you for the volume. And we can scale this down. And just for a quick cost comparison, you can get blocks at Costco for about $17 a pound. I do it all the time. We can make blocks for $1 a pound and sell it for $9. I'm so excited for this go-to-market strategy. I'm a marketer. We know that plant-based foods will get into people's habits if they're introduced through a carrier. What that means is you probably saw it happen with Oatly and oat milk. They use coffee as a carrier for their oat milk, and now it's probably in your cereal every day. We're doing the same thing, but with bagels and lox, starting in New York City and in Boston. Then we'll move to specialty retail and co-ops to work with health and eco-conscious consumers, and then into regional chains and to B2B. We have an incredible team. I'm Karina. I formerly worked in salmon conservation, and now I work at VIA, which is a transit tech startup. I shouldn't say startup. We're valued at 4x unicorn status at this point. Jennifer, our co-founder, is a published scientist and researcher, and again, built this incredible machine that's a copy of what we have in the lab. And Kate has a deep background in management consulting and to scale tech initiatives across the state and national level. And beyond anything, beyond all our technical skills, there's a quote from Naval Ravikant that says, if you can't emerge, oh my gosh, let me try that again. If you can't imagine working with someone for a lifetime, don't work with them for a day. I would happily work with both these women for the rest of my life. We've accomplished so much. We've spoken to leaders of the Bezos Center for Sustainable Protein. MRE developers at the US Army are willing to take our samples and test them. We've talked to former executives at Nestle. We've visited the lab. We're fully incorporated in Delaware, and we can issue equity. And I have a very exciting announcement tonight. In my pocket is a license option for use for seafood from the Tech Transfer Office at the University of Massachusetts Amherst. And we are ready to sign tonight if we get funding. And they are ready to countersign. So, thank you. We're asking for $50,000. We can do a lot with that. We want to secure our license, that's in my hand, and catalyze the $350,000 we need to help fund the UMass Food Science Lab and also work on our manufacturing process. We want to work on a go-to-market validation, understand our customer better, and potentially fund parallel work on odor and flavor to get to market faster if we can't find the IP in the university. We're AVA. Thank you so much for listening. The future of seafood is only sustainable if it's plant-based, and we want to make it delicious for you too. Thank you so much.
All right. Hello? Yeah. Thank you so much, Karina. Okay, so we'll turn it over to our judges for some questions. Who would like to start?
I am curious, you may or may not have it offhand, but we saw some quotes of what people think of traditional plant-based seafood. Do you have any inspiring quotes of what people think of your seafood?
Not yet, but coming soon to a stage near you.
Hi, Karina, great job on the presentation, really nice. So just curious about, from a customer experience standpoint, do you think there is the possibility that this food is so tasty and good enough that you don't really need to position yourself as replacing seafood, that you're just like a new type of food that can provide you with all the benefits of nutrition that you can ever expect?
Yeah, absolutely. We considered that. And I think this is what I think about a lot, is like how food is culture and food is memory and food is family. And so we want people to have an entryway into adopting what we're making. And the way to do that is through culture. There's such a strong lox culture. I grew up eating it. I eat it, probably more than I should. And so that's what we're really looking at, is how do we get people to enter in a way that feels safe and familiar to them, and then we can expand into, the sky's the limit in terms of how we build plant-based proteins.
Actually, as a follow-on with that, because I loved the idea of the lox and bagels, Have you talked to any either independent or chain groups about whether or not they would be willing to accept a plant-based seafood source?
I'll take the first part of that question, then I'm gonna hand it to Kate, who I know is raring to go on that one. I'm a member of the Park Slope Food Co-op in New York City, and they're offering to stock it once we have an MVP, which is pretty exciting.
Yeah, and that's probably the best example we have right now. But we've seen widespread interest in people wanting to try this, so we do think there's a demand for that, and we can make a compelling business case to stores to stock this. People have told us they want to eat this.
Hi. I guess I just want to know, what is your secret sauce? Is it the process? I think you talk about the lamination process, right? Is that what's differentiating you?
Yeah, so right now a lot of the seafood analogs on the market are just sort of gelatinous blobs or squares. Our technology mainly focuses around using a blend of plant proteins and fibers in order to actually create the flakiness. And it also incorporates a layer by layer structure to actually get the layers of fish that we're also familiar with.
Okay, that is our time. Thank you so much, Team Ava. So we will take about a minute for judges to please fill out your scorecards for pitch number 1 while our next speaker is on deck here. Not to make you more nervous, but just staying.
That's okay. Getting to know everybody.
Okay, seem good. All right, next up we have David Thompson from Junto.
Thank you very much, Allison. Can you hear me? Can you hear me? Yep. Cool. Well, I'm David Thompson. I'm here tonight with my colleague Tao Dai, and together we are Junto, where we bring practicality and performance to the battery market. So many of you are probably aware, transportation is a very significant factor when it comes to global CO2 emissions, equating to about 20%. And while there's been significant strides to date to commercialize electric vehicles, this has only resulted in less than 1% of those emissions being offset. So on one hand, that might sound discouraging, but I think it also represents the incredible opportunity that electrified mobility continues to have and allowing us to achieve our climate-related goals. And the state of Massachusetts actually agrees with me on that. So they set an ambitious goal of over 1 million EVs on the road, with half of all car sales being electric by 2030. But that being said, there's considerable barriers when it comes to actual adoption. Over half of all Americans won't even consider purchasing an electric vehicle due to fear of range anxiety. And that's not to mention the over 100 million Americans that purchasing an electric vehicle is relatively financially out of reach for them, largely due to the cost of the battery, which equates to about 40% of the sticker price that you see at the dealership. So ultimately, the problem today is pretty simple. Today's electric vehicle batteries perform too poorly and cost too much. So there's been a lot of efforts to improve this. As many of you are probably aware, lithium ion currently dominates the market. But this is a technology that was first introduced in 1991. And I'm sure there's not many technologies that you still use from 1991, right? But we've kind of reached our energy density potential for lithium ion. So over $4 billion worth of investment has gone into what are called solid state batteries, which replace the liquid electrolyte with a solid one. And while there's incredible potential in terms of the energy density, it's failed to commercialize as a result of its challenges in its manufacturability. And to better illustrate this, let's look at a battery. So you'll see a battery kind of goes through this process of of charging and discharging. You'll see in a moment, literally the anode expands and contracts. So this is like a considerable physical issue. And when it comes to a liquid electrolyte, the liquid can easily form and adapt around to this changing surface. But when you replace that with a solid electrolyte, this is a moving target, and it can legitimately cause gaps, which creates failure within the battery system. And this is the main problem why existing solid-state batteries haven't been commercialized. And that's exactly what Junto helps to solve. At Junto, we've developed a viscoelastic inorganic glass material that kind of looks like a putty. So you'll see it has the mechanical adaptability and flexibility of a liquid with the performance and the stability of a solid. That's not to mention that it's also made using some of the most common elements, including aluminum and iron. So for years, the electric vehicle market has been capped at the energy density potential of lithium ion and the in manufacturability of existing solid state electrolytes. And Junto helps to overcome both of those barriers, allowing for a truly scalable high energy density battery. So as far as for our technical roadmap, our immediate next step is to develop a pouch cell. This is kind of the industry standard to prove the legitimacy of a battery. What we'll do with that is we'll then take that to existing battery OEMs and manufacturers like Panasonic, Samsung, whom we're already having conversations with, to establish a corporate partnership. The reason behind that is we don't want to make our own battery, we want to integrate within existing battery systems. And then that also positions us well once we go to market to work directly with these partners that are already in the electric vehicle space. I mentioned that our go-to-market is within electric vehicles, but our high energy density and safety are things you want in just about all of your batteries. So we look to go into adjacent markets as well. There's perhaps no better state to grow a startup like ourselves. We've already identified a number of different partners. Some of these folks we've already worked with, like the Engine, we've done a program through them, but we hope to continue to scale and use all the resources that Massachusetts has available. As far as our financials go, we have a target revenue of about $500 million in revenue by 2035. Just for some quick context, the current market of electric vehicle electrolytes is about $12 billion. That's set to more than double to $40 billion by 2035. I mentioned that we're also looking at adjacent markets, so things like heavy industry and grid storage will help us to enable more revenue diversity and ultimately long-term sustainability. So as far as the team goes, I'm really happy with this team. Tao Dai, who's over here, he'll join me in a second. He's been working on this technology for over 11 years. He's like literally the world expert in this, so there he is right there. I bring a manufacturing background, so it's a really good chemistry between folks that literally make stuff in the lab, and then folks like myself, and then also people that we've worked with that can help translate that into legitimate products. So in short, Junto helps to make high energy density batteries practical and ultimately making a big leap forward towards net zero future. Thank you.
All right, thanks so much. Judges, over to you for questions.
Hello, thank you. Great presentation. So I understand that a major challenge with solid-state batteries is the high manufacturing costs, much higher than those for a liquid electrolyte. Can you expand on how you are mitigating that issue or solving that issue?
It's a great question. So it's both on the material cost and the actual manufacturability of the product itself. So since we're using aluminum and iron on a material cost basis, we're about 1/7 of the cost when compared to other solid-state battery electrolytes. And then given that it's a putty, we can easily kind of use a roll-to-roll manufacturing process. And we've actually already talked to different chemical manufacturers that we hope to partner with.
All right, I'm going to hop on here.
Yep.
Now, the big hindrance for pretty much any technology that comes out of the lab is scalability.
Yep.
And I'm watching both of you go, yeah.
Yep.
So I'm wondering what scale you're at, and then what is your target scale for first testing?
It's a good question. So currently we're developing in a laboratory setting. We've made a coin cell, and kind of our next immediate step is the pouch cell. Like I mentioned, that's kind of the industry standard of like really proving a battery. So that's going to be what we're going to take to the battery OEMs to hopefully establish those partnerships. But like you said, this is a very long road ahead. So realistically, to actually get this into a car, we're looking at 10 years probably to be realistic. But we hope to get there.
Yeah, I think it's interesting choice to stick with aluminum and iron, which is relatively cheap.
Yep.
What other challenges do you see from a material or manufacturing process standpoint?
Yeah, Tao, do you want to take this one?
Yeah, I think that would be the moisture. So the atmosphere, how to control the atmosphere. I think that is extra cost, but that should be very low, much easier than the sulfide, the mainstream technology.
50 seconds. So I'm just trying to understand what would be the business that would come out of this. So is the plan to produce cells, battery packs, the full-scale EV battery? What exactly is, or licensing the technology?
Yep.
Can you just talk a little bit about that?
Yeah, it's a great question. Obviously, building batteries is a very hard thing. So our plan is to just simply license the electrolyte and kind of be a component to a Panasonic or an existing kind of battery OEM. Yeah.
What electrodes is it compatible with?
Yeah, I'll give this to Tao.
Yeah, we have new cathode, 500 milliampere hour program, which is I think it's triple than the FP cathode if you know some traditional liquid ones. And we have new anode. And yeah, so we have more than 11 IPs to protect those electrolyte and cathode. Yeah.
Yeah, so it both works with existing anodes and cathodes within the market. But like Tao mentioned, he's been busy in the lab and actually doing additional research that could help to accelerate this technology even more.
Okay, thank you so much, Team Junto. All right, we'll let the judges do their scores while we get ready with our next speaker.
Okay.
Just make sure, like, there's a live stream. If you're turning and talking, just take the mic with you so you're not like.
Okay, so just like this. Okay.
All right. Okay, looks good. Next up, we have Jackie Vandermel with Ocenith.
Yeah, thank you. So we're Ocenith. We're the NVIDIA inside of clean hydrogen. We're projecting the trillion-dollar industries that run on it. So for over 200 years, the world has run on fire. Refineries, engines, but with the clean energy revolution, we're looking to replace that with water, electricity, and precision. But inside that, there's a hidden villain, bubbles. In every electrolyzer, which is a machine that splits water into hydrogen, bubbles cling to electrodes, which blocks the reactions. And the cost, up to 20% of clean energy lost. This is adding up to $1 per kilogram added cost to hydrogen. And at scale, this means billions of dollars in terawatt hours wasted every year. If hydrogen is ever going to beat the fossil fuels, then we have to solve the bubble problem. But really, why does this matter? At the core, heavy industry accounts for 30% of CO2. And hydrogen is the only scalable way towards decarbonization. However, a green hydrogen costs 2 to 3 times more than fossil fuel hydrogen. And why? Because of electrolyzers. And in electrolyzers, the inefficiency is showing. And so we've talked to OEMs, and in order to make this more efficient, they said, if you give us 5% efficiency, that would be valuable. If you give us 15%, that would be game-changing. With the current inefficiency, they have more costs towards maintenance, and they have to overstack on their stacks. So our solution, Ocenith, Ocenith is the world's first sound-powered efficiency booster for hydrogen electrolysis. It's a drop-in module requiring no redesign that sends tuned sound waves through the electrolytes, and it shakes bubbles free in milliseconds. Ultimately, this is the turbocharger for green hydrogen production, as it's quickly scalable and it can be applied to the stacks. Here's a video showing part of the bubble. And so the impacts of this are immediate. We have 15 to 20% efficiency. This is what is lowering the cost of hydrogen per kilogram by nearly $1. And at scale, that's billions of dollars. And then it's also lowering the CapEx, as well as lowering the OpEx, as there are changes to less downtime. And we've validated Ocenith across every angle. We've talked with over 200 OEM engineers and executives, and they have all agreed that electrolyzer and making it more efficient is the key towards hydrogen production and efficiency at scale. So we've demonstrated already 20% of efficiency gains at the bench. We've had hundreds of these interviews confirming that bubble removal is the top efficiency layer needed. And we are also in conversation with the top 5 global electrolyzer OEMs to scale this technology and do initial pilots. Ultimately, we've been validated by researchers, proven in tests, and we're moving into the markets. Now, looking at the market potential, we're unlocking the true efficiency layer for hydrogen and beyond. We have over $47 billion in TAM, as this is not just applicable to electrolyzers, but it moves into green steel, ammonia, shipping, among many other markets. Additionally, the demand for this is actually going to triple by 2050. And so we see by 2034, the market is growing by 27% per year, and it's going to exceed 10 billion. And then our SOM, as we have royalty streams, it's looking at 425 million per year. As for the competition, most of the competitors are stuck in incrementalism. So we have ITM Power. They have lower efficiency gains. And then we have Hysata, which is good in the lab, but very hard to scale at a high rate. And we have Enapter, which has modular flexibility, but not higher efficiency. So we're addressing these exact new areas with 15 to 20% efficiency instantly, proven in the bench tests. We have low CapEx impact by retrofitting existing systems rather than having to redo the entire stack. Our OpEx effect is much lower, and our scalability is universal as we work across various different industries, first with alkaline systems, but far beyond into others. With our business model, we have 3 parts. So the first part of our revenue model is we have royalties on every electrolyzer shipped with Ocenith inside, so it's OEM licensing. Overall, our business model is capital light, high margin, and recurring. Second part is retrofit kits, plug and play upgrades for thousands of megawatts already deployed. We see 250 to 1 million per site here. Third is expansion licensing, so expanding those patents into many other industries. This is our path to 100 million ARR. Our first phase is the pilots and validations with the top OEMs. Phase 2 with the more global OEMs and licensing at scale, and then platform expansion. This is our team. We have world-class expertise and engineering experience and ability to prove execution. Ultimately, we can't wait for another material miracle. So we're defining hydrogen efficiency as a new competitive standard for heavy industry. We are making efficiency more competitive and hydrogen more competitive by popping every bubble in the way. Thank you.
Awesome job. Judges, over to you for the questions.
Sure, quick one. Can you help me understand, what does this look like? What's the form that we're talking about here? You mentioned sort of retrofitability, but also being able to build it within the manufacturing process. What's it feel like? What does it look like?
I can actually answer that question very quickly. In the current lab bench scale test, it's a subwoofer. And what this would look like on actual industrial scale, we're still figuring that out, but literally all you need is something that can produce vibration in the range from 50 hertz up to about 500 hertz. So pretty simple.
What kind of protection do you have against this if it is something as easy as a subwoofer?
That's also a good question. We are still working on the IP side of this. We don't have anything secured yet. The thing that is noteworthy is that there have been lots of systems using high frequency oscillation, ultrasonic, to achieve cleaning, to move things around on sort of a small particle scale. This is not yet done, at least at large commercially. So we don't have any IP blocking us, even though we don't actually have the IP in place yet.
You guys mentioned about using this to produce green hydrogen, but can you just talk a little bit, does that apply to any type of hydrogen production type of process? And then I guess on top of that, just comparing the efficiencies that you gain on the hydrogen production versus the cost on the value chain of delivering the hydrogen.
That's a great point. It's undebatable that the cost of the fuel, the feedstock cost, is a large hurdle to clear here. But we are seeing there are places, specifically next to hydro dams in Canada, right, where you can get really, really cheap electricity intermittently. So siting is a big part of the green hydrogen, but also that efficiency cost of the electrolyzer is also a big part of it, as well as the equipment life of the electrolyzer. That's where we come into play. And we believe that will unlock more market.
All right, that's our time.
Thank you.
Right, again, we'll take just a minute for judges to score, to get warmed up. Also, I definitely lied about holding your applause. I like all the applause that's happening, so please keep doing it. All right, are we ready-ish? Okay. Okay, next up we have Nils Klinkenberg with Novo Blades.
Good evening, everyone. Can you hear me okay in the back? That's good? Good evening. My name is Nils Klinkenberg, and I am very excited to talk to you tonight about Novo Blades. We are designing the next generation of wind turbine blades. Our startup is working to de-risk, optimize, and validate a patented technology out of a national lab with the goal of bringing it to ready for acquisition within 3 years. That's us. Imagine yourself in a lake, in a canoe on a lake. You pull your paddle through the water, and as you do, you notice eddies spinning off the tip of that paddle into the lake. They're natural, even beautiful, but each one carries away energy dissipating into the lake rather than propelling your canoe forward. A similar phenomenon occurs with wind turbines. As the turbine spins, turbulent swirls of air trail behind the blade tip. Each one is called a tip vortex and carries away lost energy not being captured by the turbine, adding up to a missed opportunity worth hundreds of millions of dollars per year in revenue for the US wind industry. Now, we all know we need more clean energy. One recent study projected United States electricity demand skyrocketing 25% in just the next 5 years with the rise of AI data centers and electrification of vehicles, buildings, and manufacturing. The wind industry is already playing a large role in helping meet this demand. Wind currently provides fully 11% of United States electricity production and 20% in Europe, but still more is needed. To that end, the wind industry is investing heavily in the pursuit of innovation. The 3 large wind turbine manufacturers operating in the United States compete fiercely with each other in a continual arms race to improve turbine performance and extract ever more energy out of the wind. The key metric they seek to optimize is annual energy production, or AEP. And even a 1% increase in turbine AEP is worth $250,000 per year in revenue for a typical wind farm. Everyone in industry we talked to said that just 1% AEP increase sways decision makers in manufacturing, in financing, and in wind project development. In short, the wind industry desperately wants to increase annual energy production from new and existing turbines. And this is where we come in. NovaBlades is de-risking, optimizing, and validating a patented wind turbine blade design developed at the National Renewable Energy Laboratory in Colorado that uses supercomputers for advanced aerodynamic analysis that goes beyond traditional wind turbine design of the past. We're very excited because this design has been shown to increase that metric of annual energy production by 2% or more. This modified blade tip unlocks the potential for an average wind farm to produce millions of dollars more revenue over its 20-year lifespan while making the turbines quieter. And it's not just relevant for wind. This technology holds additional potential for applications in aviation, in marine power, and marine propulsion. Even just within wind, the market for this is huge. Wind is a large industry and still growing, despite some political turmoil around offshore wind in the United States that you may have heard about in the news. And yet, we have identified 3 specific submarkets that are growing strongly and that are perfectly poised for adoption of the NovaBlade technology. The first is new onshore US wind farms, more than 90% of which are built on private, not federal land. The second is replacement blades for aging wind turbines, a rapidly growing trend known as repowering, which provides the opportunity to maximize return on investment and energy production from existing assets without the need for new permitting processes. Finally, offshore wind in Europe is growing very rapidly and perfectly poised for introduction of new technologies like this one. From conversations, dozens of conversations with experts all across the wind industry value chain, we've determined that the most promising path to market for this sort of technology is going to be through acquisition by a wind turbine manufacturer. They regularly acquire IP externally, and we plan to follow that proven path, targeting an acquisition value in the range of $5 to $15 million. We've already incorporated, and we're in discussions with the National Lab for an exclusive license for this technology. Moving forward, we plan to raise funds, optimize the design further through computational fluid dynamic analysis and simulation, which is industry best practice, moving on to physical testing at scale with industry partners, aiming for commercialization in 2027 and beyond. Industry told us that 1% turns heads. If we can validate 2%, that's game-changing. And we have a fantastic team with the experience and track record of success to make this happen. I bring more than a decade of organizational and team leadership experience and a background in mechanical engineering. Judith Underwood has decades of industry experience and has advised more than 70 climate tech startups. And Justin Reel is a former oil and gas management consultant, a Babson MBA, and founded, funded, and recently exited his own tech startup. We also have a fantastic relationship with Luis Antonio Martinez Tosas, the inventor. Hi, Tony, out there on the live stream. He's been incredibly supportive of us throughout this process, very committed to the technology, and we all look forward to bring him on board when funding permits. Our ask today is for connections to wind industry experts, startup advisors, and sources of funding. We're really excited about this journey we're on, and we'd love your help.
Great job. Judges, who would like to ask the first question?
can start us off. So it's a sort of novel design for the tip of the blade. You mentioned that it's kind of a analytics, like a design, kind of computational design problem. Why hasn't it been done before? I mean, you mentioned all the R&D going on at these folks.
We had the same question. It turns out, I'd love to give you a long answer and anyone a long engineering answer afterwards. The short answer is traditional wind turbine blade design is extremely computationally intensive. Accurately modeling airflow over devices that can be 150 feet long or more is very difficult. There are mathematical shortcuts that make a lot of sense. Airflow mostly happens over the blade sideways, and those shortcuts model that, but don't account for airflow transversely along the blade. These harder techniques, frankly, do, and that's how this design was developed. The short answer.
So you are thinking very large, which is awesome and a great market. What happens if you think small? Like, could you put this in a computer?
Based on conversations with the inventor, the aerodynamics of this work at the large scales. They were open to testing that otherwise, but that's also where the big opportunity is. We considered small scale turbines because there are, like, at a wastewater treatment plant or a farmer puts up on the farm. 2% improvement doesn't sound like a lot in general. It's huge on wind, and industry kept telling us again and again, like, that would be amazing. Even 1% AEP, they'll fight tooth and nail over that. But at the small scale, it's just not that valuable. Yeah.
So the tip of a wind turbine blade is a pretty spicy place. I mean, there's a lot of forces acting on it, moving pretty quick. What's kind of the structural implications of having an extra thing on the end of it?
Yeah. There are some. That will be one step in the validation process. This is an innovation in aerodynamics. It's extremely promising. And yes, before a product gets to market, structural analysis, like with any change in wind turbine design, will need to be done. Through MassCEC, we're able to connect with the Wind Turbine Testing Center, Wind Technology Testing Center that MassCEC runs. They do structural testing there. We may get a hookup from them and at least the expertise from there. So that's on the road of development, but first and foremost, the aerodynamics and getting that right.
All right, that is our time. Thank you, team. Nice job. All right, we'll take another minute for our judges, and then we have one more pitch before our break. All right, judges, are we good to go? Just about. Okay. Now let me introduce Ben Lamb with Elementra Technologies.
The great philosopher Weird Al Yankovic once said, "Can't get enough of it. Beer. How we really love it. Beer." And here at Elementra Technologies, we agree. But we're not just talking about what's in your glass. We're talking about what's left behind. Millions of tons of spent grain. And as it turns out, that beer waste might just help solve a The fermented beverage industry in the US alone produces enough spent grain each year that, if allowed to decompose, would release to the atmosphere over 5 billion cubic meters of methane, a primary greenhouse gas. For context, that's the equivalent to the entire emissions of 750,000 cars in a given year. Meanwhile, in a far less tasty sector, today the US fertilizer industry manages over 1 billion tons of waste gypsum, a toxic calcium-rich byproduct of their production process. To put that in context, that's equivalent to 4.4 million statues of liberty combined. And they're adding millions of tons more to these stacks, costing the US fertilizer industry over $500 million every year, not to mention the ongoing risk mitigation and management expense that they have for decades. So we have two wildly different waste stream problems, both massive, both contributing to climate change. But what if they could solve each other? Well, here at Elementra, we're working with a proprietary co-located bioreactor system, which brings these two waste streams together, spent grain as a carbon source, gypsum as a calcium source, to fuel a microbial community that actually converts that into solid state carbon, permanently capturing it and creating high value carbon credits while unlocking commodities like elemental sulfur, calcium carbonate, and rare earth element ore. I pressed the wrong button. This system is a huge advancement away from legacy systems, our primary competitors. We're actually removing industrial waste and biomass waste from landfills, aging sewage plants, and massive toxic waste piles. Instead, using proven fermentation models, as well as naturally occurring microbial communities, we're able to expedite what nature has done for eons, taking those traditional processes of waste management that take months or years and completing them in mere hours. And I just blanked out. And this is just the beginning. Oh my goodness. This is just the beginning. We have massive opportunities to continue to grow this through additional industrial waste streams and biomass streams, potentially unlocking a $1.2 billion carbon credit market. Because the reality is, we've got, holy cow, we found a unicorn that turns waste into wealth. We've identified an initial $110 million beachhead market, just using domestic brewery waste and gypsum already stockpiled in Florida. Shockingly, the gypsum waste from just one fertilizer manufacturer can actually power our system for 30 years and help to sequester over 200 million tons of carbon. But that's just the beginning. There are massive industrial and biomass waste streams to be integrated into this system, potentially unlocking a $1.2 billion carbon credit market. Because the reality is, everybody poops. Which means we have loads of future growth potential. Whether it's the 1.4 billion tons of agricultural animal waste produced each year, or the 51.7 billion tons of human waste going through sewage plants, our system can actually be adapted to integrate the biomass streams that I know for a fact you all create. So when I say this is just the beginning, I'm really not shitting you. In just 16 weeks, our team has validated our market with stakeholder calls across 13 different industries. We've developed key relationships with fertilizer producers and beverage manufacturers, and we've developed a tactical next phase plan for R&D and pilot deployment. Additionally, we've gained serious early momentum. We have 3 letters of intent, including a municipal wastewater plant, a third-party research facility, as well as a fermented beverage producer. And as of last week, we were accepted into a stage 2 tech accelerator to propel us forward with additional lab space, network connections, and technical assistance. Between now and November, we will finalize incorporation and licensing, moving forward in 12 months of accelerated R&D, which will bring us forward to a 16-month pilot installation. This isn't just a dream, it's actually happening. We have the dream team. Oliver, one of the inventors of the technology, developed it at MIT and has developed key expertise across postdocs in his lab. Rai an aerospace engineer with a heart for climate, brings technical drive and a passion for sustainability. Rishabh brings over a decade in clean tech experience with over $400 million in projects delivered and leadership in commercialization. And me, I bring 2 decades of organizational operations with deep roots in academia, business growth, and technical partnerships. We have the secret sauce. To propel this forward, we're seeking $300,000 to support licensing, research capacity, and initial R&D operational overhead, bringing us to a bench scale prototype. We are Elementary Technologies. Come brew up something amazing with us. Cheers.
Judges, over to you for the questions.
Thank you. Could you discuss more about your proposed business models? You're going to be co-locating the reactor and then selling limestone and then carbon credits. If you could just expand on that.
Yes, certainly. So we plan to own and operate these bioreactors and plan to co-locate them to the waste streams. What you see here on the right side is essentially how we want to scale the system. So right now we are at half a quad system size. So over the next 12 months, we want to establish proof of concept 16-gallon system. And then over the next 4 years, we develop it to 1,000-gallon to 10,000-gallon, and then eventually 50,000-gallon system. What you see on the left is the different commodity pricing that we would be trading on the commodity markets. Next slide. And as we extrapolate that over a 5-year trend, we would be, once we are at a 50,000-gallon scale, we are commercially viable.
Is there any restriction on the type of waste you can consume here? What kind of waste cannot be used here in the process?
Hi, can you hear me? Okay. So basically the waste that we're looking for is carbon-based and calcium-based. The technology initially is targeting wastewater as well as gypsum. So that's really what we're targeting in at least our pilot. In terms of wastewater, there are a lot of regulations around municipal wastewater, so there's kind of a limitation on what we can do there right now. The processing systems that are in place are really designed to do one thing and one thing only. That's why we're starting with the brewery industry. We know that people who love beer love the climate, and it's just a good place to, like get our feet on the ground, start with local businesses and all that. So we have big plans for the future for sure.
And to add to that, gypsum is highly regulated, so it is just sitting, not utilized. And while we process this, what comes out of it is not toxic anymore. So that's the biggest advantage of the process.
So can you talk a little bit about whether the carbon credits that you can produce, if they would be considered to be certified carbon credits, and if there is an additional validation that you need through your process to get there?
Yes, certainly. So we have established contact with some of the registries who regulate this, and the feedback we have gotten so far is that ours is one of the, you said, a Cadillac of carbon credits because it is solid. It is permanent, and you can literally weigh what we produce and do the math of how much carbon credit you have. And it's very rare to find that in the industry today that you can actually validate by just measuring it. So yeah, we have spoke with multiple partners, and there's significant interest from them. Awesome, thank you.
Alrighty, thank you, team. We're gonna take a quick break. So please feel free to get up, stretch your legs, network. We're also gonna try to squeeze in a few more chairs, so hopefully everyone can have a seat when we come back. All right. Hello. Welcome back, everyone. Thank you for staying with us for part 2. I know many of us just inhaled some hors d'oeuvres, so hopefully you are satiated, but still hungry for more pitches, of course. You are in luck because we have 4 more to go. So I'm excited to introduce our next entrepreneur, Travis Hampton with Thalon Materials.
All right. Hi, everyone. I'm Travis Hampton, and I'm here pitching on behalf of Thalon Materials, where we're turning brine into magnesium. A lot of you are probably familiar with magnesium in sleeping aids or antacids, but magnesium is so much more than that. In its metal form, it's a critical material. It's what's deemed a structural metal like aluminum or steel, yet it's 35% lighter than aluminum with similar properties, and it's a proven and essential material in the automotive, the defense, and the aerospace industries. Yet, the US doesn't produce any of it. China controls 90% of the production of magnesium, and on top of that, the magnesium production process emits 5 times more carbon dioxide than the steel production process itself. But it wasn't always this way. In the 1940s, Dow Chemical Company pioneered magnesium production down in Freeport, Texas, just 50 miles away from where I'm from on the Gulf Coast. But that process stayed the same. And over time, one by one, plants closed due to outdated methods, environmental damage, and non-competitive costs. But we're here to change that. We're bringing magnesium production back to the US. And while we're at it, sourcing clean and reliable magnesium for the rest of the world too. We use a 3-step process. We start with seawater. So magnesium, it's in the salt inside of seawater, one of the most abundant elements on the earth. And we take that seawater, dehydrate it down to magnesium oxide. We take that magnesium oxide, place it into step number 2, which is our core innovation, an electrolysis process that splits apart magnesium from oxygen. We take that offput, put it into step 3, where we distill it down into a high purity magnesium metal that we sell into already existing supply chains. There's 3 things about our process that I want to make sure you take away from today. And that is, first, we don't produce any toxic chlorine or dioxin gases. Those are those same polluting and damaging chemicals that forced a lot of the closures in the US previously. The second one is that we produce 50% less carbon dioxide emissions than the state-of-the-art magnesium production process today. And third, we're cost competitive. So what are we competing over? We're competing over a $6 billion market globally, but more importantly, a healthy and strong market for magnesium in the US and Europe. Right now, the US has already announced that magnesium metal is one of the 13 critical elements that they need for a high security. And they've already announced $1 billion in funding opportunities over the next year for critical minerals, such as magnesium. With a beachhead in the defense industry, we've already done a lot of our groundwork. We've talked with Boeing materials engineers, we've talked with industry lobbyists, and we've talked with automotive parts suppliers, all emphasizing the need for domestic production. If we look at our peers, they sit in 2 main groups. The first one is the Chinese manufacturers and producers emitting lots of carbon dioxide and using a subsidized process as well. And the second group is the magnesium startups here in the US, a few of them. However, those 3 magnesium startups, also early in their innovation cycle, use that same outdated magnesium chloride electrolysis process that Dow Chemical pioneered. They're just improving on the efficiency of the dehydration step. We can beat them on emissions and cost. We're moving fast. We've already incorporated, we're planning to license the technology soon, it's patented and protected, and it's already produced magnesium metal in the lab. Over the next 2 years, we're planning to build our prototype, and to do that, we know it's not easy. We've already talked and engaged with both engineering firms and metallurgy experts that have validated our scope and offered up facilities for us to pilot inside of. We'll be needing $500,000 in funding to reach that next step, and we'll also be in 2026 pursuing venture funding to further fuel our growth. We've got an experienced and driven team. We're excited to be able to bring magnesium production back to the US and bring with us our experiences across Shell, GE, Harvard Business School, and our deep metallurgical expertise to be able to get us there. So, as I've already pointed out, we're going to be seeking funding soon. And so that's the first test that I have. If there's anyone in the non-dilutive or venture funding space, please come and talk to us. We'd love to extol the virtues of magnesium metal and what it can do in industry. And second, if there's anyone with metal supply chain expertise or connections, we'd love to talk to you as well. So thank you so much. We're excited to be bringing magnesium and building magnesium from brine. Thank you.
Thank you. Could you expand on your cost competitiveness?
Sure, yeah, absolutely. So magnesium metal is currently brought into the US market at about $7 a kilogram. We can do that about $1 or $2 cheaper than that, and that's our competition. There's no current process that's being produced inside of the US. So those are our cost targets right there, if that quickly answers. Okay.
You mentioned that your improvement over the other small startups that are currently working in the US is that you have a different process, and their improvement over China was a difference in dehydration. But you also said that you require dehydration. So can you clarify your benefit?
Yeah, absolutely. So I think there's, actually, do you want to go ahead and take it with the technical?
Sure, okay. Yeah. So there are basically two processes right now. There's the chloride electrolysis process, which involves dehydrating magnesium chloride, which is extremely expensive. You have to do it in a superalloy vessel in a hydrochloric acid environment. So you have expensive raw material with an efficient electrolysis process. The other, the Chinese process, they use a low-cost raw material, magnesium oxide, which is dehydrated very cheaply from the hydroxide. You just heat it in air. And then they have a very expensive and inefficient process to go from there to magnesium metal, extremely labor intensive. We have low-cost magnesium oxide in a low-cost electrolysis plant. We can retrofit an aluminum plant for our electrolysis portion, reducing our capex by 50 to 80% and our time to market by half, roughly. So it's many different cost improvements versus what's there.
So is that where the seawater piece comes in? That's a really inexpensive feedstock that you guys can use instead of, I guess, is it the kind of equivalent to whatever the low-cost feedstock they're using in China is?
Yeah, that is equivalent. So like on the feedstock side of things, yes, that's correct. So the seawater, we can dehydrate down. That's what we would use. We can use already off-the-shelf technologies for that dehydration step, and that's where we tie it in.
Can you just elaborate a little bit more on the business model? So are you planning to build these plants and sell magnesium, or some different business model?
I think the baseline that we are targeting is to build the plants and sell magnesium. That's correct. And Adam already mentioned kind of some of the advantages that we have on the CapEx side compared to our peers in terms of reutilizing aluminum smelting capacity. But we also recognize that there's plenty of opportunities before that kind of build, own, operate step, that final step, of partnering with already existing aluminum manufacturers like Alcoa, Rio Tinto, to be able to bring this process into their house and make a partnership there. Yeah. All right, I think that's time. Thank you all.
All right. Thank you, Team Thalon. All right, judges, are we good? All right. Okay, next up we have Arya Sosne with Hefion Separations.
Hi, my name's Arya, and I'm here today as co-founder of Hefion Separations. I'm beyond excited to talk to you about how Hefion is bringing smarter, cleaner lithium recovery to the world. So there is a growing demand for lithium battery technologies, whether that be in electric vehicles, in battery storage for energy-intensive technologies like AI data centers, or for improving grid resilience. And alongside this demand, what we also see is that the supply is not catching up. So by 2030, we predict a 160,000 metric ton supply shortage equivalent to $4 billion. Now, the current way of sourcing lithium is a pretty intensive process. It involves either brine extraction from places like Chile or lithium mining in places like Australia. This lithium is then shipped to China for refining and celling manufacturing, and then shipped to the end use case. So a battery that you might see in an electric vehicle on the road in Boston goes through this entire process before it reaches your home. Now, not only is this process very intensive and transportation heavy, it's also at risk for global supply chain disruption and has major environmental costs. So that 160,000 ton shortage that we talked about earlier has a cost of 34 billion gallons of water, or 3.3 million metric tons of CO2. That's a lot. So how do we solve this? Well, we can turn to recycling, but lithium recycling right now involves processes like hydro or pyrometallurgy. And what it looks like in battery recycling is that it's not actually the best at extracting lithium. So current battery recycling processes, in order to extract lithium, they need to be incredibly precise. And this is really costly. And so what most recyclers end up doing is either discarding the lithium or extracting it at cost to themselves. Current battery recycling for lithium is broken. We have a way to fix that. Hefion Separations offers an electrochemical technology that is not only easy to scale and compatible with off-the-shelf hardware, but also offers cleaner, more efficient recovery of lithium. So we aim to start by getting lithium out of the waste streams from battery recyclers. This process is easy for us to drop in and requires minimal replumbing for the recyclers. It also offers them new lithium revenue streams. Then we hope to scale by participating in lithium first recovery. Now, not only does this make the process of lithium easier and you can extract more of that lithium, but currently lithium acts as a spoiler in the battery recycling process. So by extracting the lithium first, recyclers are able to actually simplify all of their downstream processes. Now, this go-to-market strategy was customer-led. The customers told us how they wanted to use our technology in their processes, and by having this dual-pronged approach, we're able to scale with our customers. There is significant market opportunity in this space. Our beachhead market, where we're using that waste lithium from the bleed stream, has a market size of $470 million. Expanding to lithium first recycling has a market size of $3.1 billion. Then expanding to battery metals in general, that's $10.4 billion. And based off of conversations that we've had with industry experts and primary extraction experts, there is a significant primary extraction follow-on market of $57 billion that we can tap into. Also, the timing is right for this. We've talked to process engineering firms that serve battery recyclers, as well as battery recyclers both in the United States and abroad. Our early customers want this technology, and they've told us exactly how they plan to use it in their processes. There's also significant federal support for critical minerals at this point. There is $1 billion of new funding that was recently announced targeting critical minerals, including targeting technologies in lithium separation. We aim to secure initial funding in 2025, then move on to scaling and validation testing through 2026, deploy our pilot and commercial facilities from then. I am very excited to be working with a team of experts, from Jocelyn's expertise in commercializing new energy technology to Jeremy's expertise in major large-scale product development, and my background in energy policy and product. We're also supported by a world-class research and inventing team, Dr. Weila Yan and Dr. Maitreyi, who is here with us today. So today, we ask you to join us, Hephayon Separations, as we bring smarter, cleaner lithium recovery to the world. Thank you.
Hi. So is the core technology around the membrane, and how do you make it more efficient for extraction?
Yes, thank you. So the core technology is a highly selective membrane that drops in and is compatible with all the commercially available hardware systems. And that allows us to be very efficient in terms of capital cost. And this membrane essentially is a novel membrane created by Dr. Yan and Dr. Maitreyi, who's here. It's extremely selective for lithium, specifically for lithium over the transition metals, which include nickel and cobalt and iron. It's also extremely selective for lithium over magnesium. And so in a battery recycling context, it's very, very difficult to separate lithium from the transition metals. We have a superpower in that we're able to do that very efficiently with very high selectivity and essentially improve the entire flow of the battery recycling process by doing so.
And could you explain if you have any patents?
Yeah, so the IP is with UMass Lowell. Patent applications are filed and it's in progress.
Did you apply for the ARPA-E recovery grant?
Not yet. We are looking at, frankly, we've had some very exciting announcements in critical minerals in the last few weeks, and we are looking at a future with quite a lot of federal funding and potentially other sources of funding coming into this space. It's really exciting that the DOE made this announcement and targeted lithium separation in particular, and they're doing that because they see the same things as us. They see the supply shortage on the horizon, they see the supply chain vulnerability, and they want to address it, right? And they don't want all the waste to happen. And so we see a lot of opportunity on the horizon, and we are working to be ready, let's say, to ride that wave and ride that wave right to commercialization.
Okay, thank you so much, team. Wow, okay, that works.
Thank you, well done.
All right, we'll take a moment for the judges. Should have prepared some fun facts or something for this 1 minute downtime. Next time. Here, Dan, do you want to make sure you get your... Easy enough. All right, are we ready? Okay, next up, I'm pleased to introduce Dan Doble with Loop Chemicals.
Well, thank you, Alison, and welcome everyone to Loop Chemicals. We're delighted to share with you our plan for disrupting the ammonia industry. So first, some background. So nitrogen is an essential element for all life on Earth. And most of the nitrogen in the food that you eat comes from ammonia fertilizer. Now, there's a huge market for ammonia fertilizer. It's actually the largest commodity chemical there is by volume. And this volume is forecast to increase dramatically in the future, as you see, basically because the world is going to be eating more food. So there's an enormous future market emerging also for ammonia as a fuel, a replacement for carbon-based fossil fuels. It can either be used directly or as a carrier for hydrogen fuels. Now, despite all these benefits, there's an enormous problem with ammonia. It's responsible for 5% of greenhouse gas emissions. And this is primarily because it's made from large amounts of fossil methane in its manufacturing. So our plan for the future is, instead of manufacturing ammonia from fossil fuels in large centralized plants, we are moving forward to this. This was made actually by my daughters. And we're envisioning a future world where we have small-scale distributed ammonia plants, and they will use local clean feedstocks and renewable energies. So this is a map of the world, and we're showing here the percentage of the local ammonia price which is attributed to transportation. And as you can see, when farmers pay for ammonia, a significant amount of the cost is going towards transporting it there. And we aim to eliminate this cost. So we need a technology which works well at small scale. So we're working with Sandia National Labs and also ASU on a chemical looping technology. Now, there's a lot of things which go into this technology, but let me just say the most important is you can produce ammonia at much lower pressures than under typical conditions. Low pressures means lower capex, lower operating costs at small scale. So this is the market adoption curve which we envisage for ammonia. And actually, it's not just us. This is envisaged by several other people who we talked to. And we're going to attack this market with a two-pronged plan. First of all, we're going to come in with incumbent technologies, which have recently been downsized to small scale, semi-economically, and we're going to be developing projects. At the same time, we are developing chemical looping. We're getting it ready for commercialization 5 years from now, just in time to hit this massive increase in adoption. So we're going to be both a technology developer and a project developer. Okay, and we're already making tremendous progress on this strategy. So we're proud to announce the development of this NitroMap tool. So this enables us to pinpoint the best locations for manufacturing ammonia in agricultural regions. So here, zoom in, this is a region of the US Corn Belt. Basically, this is a heat map here of the cost differential between the old way of transporting in ammonia from the outside versus manufacturing it locally. And this is how we're going to differentiate ourselves from other project developers out there. Okay, so we're making progress on another front as well. I'm delighted to say we have our first customer. Thank you. So Dan Olson is a corn farmer based in North Dakota, and he's also deeply involved in the bioethanol industry. So the concept we're looking at is taking corn, it goes into your bioethanol plant, we're using the fermentation residue and converting that onto ammonia. The ammonia goes as fertilizer to surrounding plants, to surrounding farms, and then we're kind of closing the loop in this circular economy. So, you know, Dan is fantastic to work with, and I guess he's very impressed by this idea and ourselves, and he's written a letter of intent, and we're looking forward to working with him. So, as already mentioned, the ammonia market is a huge market, and this means there's an enormous opportunity for us and our investors to make a lot of money. So you see in the bottom here, the beauty of our approach is as we enter the market and come out with lower cost technologies, the market size actually increases. So our technology is differentiated from the others out there. These are the main criteria we use to score technologies by. Basically, we're the only one which combines low cost, low carbon emissions, and viability at small scale. So we've got a 3-year plan to get to the market. We're going to focus next year on development of the chemical looping technology together with Sandia. Get our first pilot plant running up in Massachusetts in 2027. And we're going to be scaling up the technology. Our North Dakota project will be the focus of 2028. So this all sounds fantastic. How are we possibly going to deliver? Well, speaking first on myself, I am a chemical industry veteran, 27 years in the chemical industry. I currently work for SABIC, one of the world's largest manufacturers of ammonia. I also have worked in corporate venturing for 8 years, so I know my way around the funding ecosystem. I'm delighted to be joined by co-founder Alex, he's an agronomist and data scientist, and Jonah, who's a chemical engineer. So you see, things are already gathering momentum. We already have IP license negotiations underway. We exchanged a term sheet just yesterday. We're building strategic partnerships, and we're going to be applying for funding. So we're going for grants, and we've already been approached by potential investors, and we're going to be raising $3 million next year. So final slide. It's been a pleasure to talk to you all today. Hope you're as intrigued by, as excited about the opportunity as we are. Thank you for listening.
Great job, Dan. Judges, over to you for questions.
Hi. So you mentioned that one of the key differentiations and advantage is doing this at a smaller scale. So can you talk a little bit about what does that mean in terms of how much would it cost to build a plant like this and time to break even?
Yeah, so I mentioned to you we're looking at North Dakota plant. So looking at $20 million for this plant, actually. So yeah, it's not cheap. Break-even price, yeah, I mean, we're looking at between 5 and 7 years, basically. A key thing is we're looking to qualify for 45Z credits, right? So out there under the previous government, but actually they're being increased by the new government, it looks like. And that will be worth $200 per ton of ammonia, and that will accelerate the payback time massively.
What are the inputs for the chemical looping process, and where do you source?
Yeah, so the inputs, you're going to have nitrogen, which is coming from the air, and that's going to react with the carriers, which are a part of the chemical looping process. And the hydrogen, we're thinking we're going to be sourcing from either steam methane reformation or also green electrolysis as well. So both of those are an option, and we'll be looking into whichever one is a better option for where the plant itself is. Thank you for that question.
So you, again, on the small scale piece of the pitch, you mentioned it's the largest by volume commodity in the world. So obviously some people have thought, hey, this is a really great thing to do at a really large scale. So I'm kind of curious, what is it about the technology and the business model that makes it, the kind of economies of scale work in reverse, where it's actually better to do it small and distributed?
Well, I mean, you're really eliminating the transportation cost, really. That's the primary thing, right? So why hasn't it been done before? Well, because they haven't had chemical looping before, quite frankly. So we've got an innovative technology which makes it work better at small scale, and we can save them that transportation cost.
All right, thank you. That's our time. I love the model. Thank you. Yes, great job. Want to come up? All right, just the big green button is next. All right, coming up is our last pitch, and then we'll take a break for the judges to go deliberate. As a reminder, during that break, we have all the team's beautiful posters in the back, so be sure to take a look at those, and don't forget about our digital event guide. QR code is on the back of the name tag, so if you don't have a lanyard, make friends with someone who does. Check out the QR code. Good to go. All right. Last but certainly not least, we have Elizabeth Bridges with Mira.
Hi, everyone. My name is Elizabeth, and my co-founders and I are building Mira, where we are making high-performance food colorants from plants. I want to start by asking you to just take a moment and reflect on one of your childhood birthday cakes, remembering all of that super bright frosting piled high on top of the cake. Those bright colors made the cake itself a little sweeter and the memory a little bit sharper. But this is what we didn't know then. Those colors are made from fossil fuels. It's gross, and it's still in our food today. Not because it's good for us, but because they are cheap and they work. The average adult consumes about 50 milligrams of synthetic dyes every day, and for kids, it's double that. When we think about the impact of these fossil-based dyes, carbon is really just the tip of the iceberg. There are serious health implications from consuming artificial dyes, including neurobehavioral disorders, organ damage, and even DNA damage. And remember again that our kids are the biggest consumers here. There are also serious ecological impacts. Just like the cousin molecules that make up our plastic water bottles, these ingredients do not break down in nature. They persist indefinitely in our oceans and in our soils. I also just want to add that all of this is based in science. I know there are some people talking about artificial dyes that don't appreciate that, but we certainly do. This becomes super clear when we look at a case study. So Trix in 2016 transitioned to natural dyes. They were a little bit ahead of the curve, and they had so much negative pushback from consumers saying that the cereal itself looked stale and tasted bland, even though they didn't change anything except for the color. They went back to artificial dyes in 2017 after taking a significant revenue hit. What this comes down to is that natural dyes cannot stand up to the performance metrics of synthetics, and they also can't reach the same super vivid colors. And this is Mira's opportunity. We have been very busy. We have spoken with over 150 people across the value chain, and we've hosted 4 discovery workshops. And I can say with full confidence that brands want to change and consumers are demanding it. So this is our first product. It is coming out of the pioneering research being conducted by Dr. Leila Darabi at Northeastern University. And Dr. Darabi looked to nature to try and understand how the natural world is able to produce these super vivid colors that obviously don't fade in things like sun and heat. And what she found is called structural color. So structural color is basically the way that butterfly wings and kingfisher feathers are able to produce these really, really bright colors. And just like in nature, the process Dr. Darabi has designed results in a really bright product that's super stable, UV resistant. It's also made from vegetables and so fully biodegradable. And it's made in a simple process with a low carbon footprint that can output a direct replacement for synthetic dyes in food. We are starting with the color that is hidden in plain sight. It's probably not what you expected me to say, but it turns out white food dye is absolutely everywhere. It's in all the things that you could maybe imagine has a white dye, stuff that's like white-ish, but it's also quite literally everywhere else. Pumpkin seeds, sports drinks. It's used in combination with other dyes to essentially change the hue. So if you're eating a blue M&M, you might think it's just blue food dye in there, but there's actually quite a bit of white to help that color get the right hue that the marketing team has identified, essentially. When we look at the market, this becomes even clearer. So it's a huge market, $18 billion, and white makes up more than half of that. Our first use case is clean label candy, and if we're able to just take a small portion of the white used in clean label candy, we're looking at a $477 million opportunity, and this is really just the start for us. Mira is able to make white, in addition to all the other colors in the rainbow, in a low carbon process, and our ingredients can stand up to the conditions used by the food industry, making us a clear standout next to our competition. Mira is a B2B ingredient producer, making food dyes and selling them directly to food manufacturers and food brands. We have direct line of sight to FDA approval, and once we've been incorporated into a food product, this becomes a recurring revenue business. Every new product, every new candy, every new beverage SKU represents a long-term supply agreement with that customer. Our go-to-market strategy starts with formulation testing. This is where we are right now. Those formulation partnerships, essentially, that we're building will result in samples. We can take those samples to pilot partners And from there, we'll be able to bring in some early revenue, de-risk those formulations, and it will set us up really nicely for joint development agreements with industry giants, the Nestle's and the General Mills of the world. Those JDAs will position us perfectly for long-term commercial offtake with large brands. As far as manufacturing goes, we are starting with what is called toll manufacturing. So we're starting with a CapEx light model because the process itself is so simple, we don't need to build our own pilot at the beginning. We can save that money and work with toll manufacturers in the early days. We, like I mentioned, have been very busy. I'm super proud to announce that we have 3 letters of intent from potential customers, and we also have a letter of support from Northeastern University, who holds Dr. Ravi's patent. And we are 3 women working to change the food industry from the inside out. I am a repeat founder in sustainable pigments, and because I've taken an ingredient from lab to market before, I know how to build these partnerships. Kritika is a climate tech investor and company builder, and she knows how to scale early stage tech. Krista is a food entrepreneur with a broad network in the Boston area, helping us to get these local early pilot partnerships faster. Along with our incredible inventor, Dr. Ravi, and our team of experts, we represent a wealth of knowledge in food manufacturing, biomimetic color, pigments, as well as food science and formulation. We're currently looking for non-dilutive funding to help with this formulation testing at the beginning, and we're also looking for connections in the food industry, specifically with food formulators and food innovation teams. And with that, I want to end on a sweet note. So I have candy that will be handed out from a local clean label candy brand. Thanks.
Great. Thank you. How do you compare in terms of costs with your competitors and the incumbents?
Great question. First, I want to point out that every single customer that we spoke to has told us, can you give us a sample today? There is no equivalent in this market that can meet the performance and be a safe product. So actually, our customers are ready to pay 30 to 50x more. But that being said, we know that food is a tough business, so we are being very conscious, and in our commercial scaling process, after a TEA that we have done, a techno-economic analysis, we've identified that we can reach cost parity with the market at commercial scale. We're actually able to reach it faster if we can scale faster, but we can get there. We're very confident.
Do you know of any regulatory tailwinds that could help with the adoption of the product?
Yeah, so back in April, the FDA announced that because of the regulatory push, that they're trying to move food colorants through the FDA process faster. We've spoken with a regulatory consultant who feels confident that with that information, in addition, the fact that all of the ingredients we're using are generally recognized as safe, that we can get through the FDA process in a time that we've budgeted, and that allows us to go to market safely.
I also wanted to add that this is one of those rare issues because kids are impacted that has bipartisan support. 30 states already have legislation, including Massachusetts, where there was a conversation yesterday to remove food dyes from children's food and our food. So we have a lot of momentum behind us.
So starting with white is kind of an interesting angle. Given that it's a different sort of colorant, a different sort of thing, does it play well with the existing state of things? Like, can you go with one of the pigments, or do you need to have a full set to kind of offer to a manufacturer?
Great question. Yes, we are starting with candy. One, because this clean label candy is a very interesting market. It is growing heavily, and they want clean ingredients, so that's why we're using white. And to answer your question, yes, there are different formats like liquid, dry powder, and other formats that are based on the product. We are starting with the liquid pigment because we know that it can easily be used in a ton of products that are adjacent after candy. But that being said, we're working on the dry one too.
Okay, and that's our time. Thanks so much, Team Mira. Oh, I can use this one. And everyone for staying with us. We'll now take another break to deliberate. So judges, if you can take your laptops, and we're gonna go up, follow Isabella and the green shirt and the big piece of cardboard up to the 4th floor. If I could also have, let's see, from FedTech, Michaela, probably Ben and Hadass, anyone from MassCEC who wants to come, and our coaches. And we'll be back here around 8 o'clock or just a few minutes before. Thank you so much for waiting patiently. I'm sorry it always takes longer than we expect because it was not an easy decision. All of the teams did so great, but the judges have made our decisions, or their decisions. And I just want to say that, fortunately, in addition to these cash prizes, MassCEC and FedTech will continue to support all of the entrepreneurs post-program with our alumni services, including the opportunity to receive subsequent grant funding and entrepreneurs in residence to support the companies in their next stage. But without further ado, I'd like to introduce Benedict Reynolds, Program Manager at MassCEC, to announce the winners.
Hello, everyone. Thank you. First, I want to congratulate all of the entrepreneurs. You have done such an incredible job. I got to see your midpoint pitches about 8 weeks ago, and the amount of change, the amount of growth, it was absolutely incredible. We should all be very proud. And I can say from the MassCEC team, we are generally very, very proud. We were smiling the entire time you guys were pitching. Now, for announcements. Do we want the checks to be up here, or they're over there? Okay. I always thought big checks were fictional unicorn type of creatures, but they're real. They exist. And we're going to see 3 of them today, which is quite remarkable. I'll start for 3rd place first, and I would love your help with doing a drum roll. In 3rd place, we have Junto. You can walk up on stage. Congratulations. Yeah. David actually rides a motorcycle, so good luck taking that home. All right, drum roll for 2nd place, please. And 2nd place, we have Mira. Fantastic, good job. And in 1st place, for $50,000, we have Phelan. Good job. Yeah. Woohoo. Great, thank you guys. Another round of applause for all the entrepreneurs. Like Allison said, there's alumni services and there are more grants to be awarded. So please, please, please stay vigilant and please stay active. And I'll pass it over to Allison.
All right. Huge round of applause for all 9 teams. Congratulations to all our winners and great job, everyone. Thanks so much. I will give my quick Oscar-style acknowledgments. I want to say thank you to all of our judges, our 3 amazing studio coaches, Paula, Victoria, and Tiana, the entire MassCEC team. They're great. Everyone at MassCEC, especially Leslie, Jen, Mariana, and Benny. All our... More applause. Our ecosystem partners across the state, our lab tech transfer partners and inventors, all 9 teams, and all of you for being here and supporting us tonight. So that's all I have. Entrepreneurs, please stick around for some group photos. Everyone else, thank you again and enjoy the last day of Startup Boston Week. Come on.